All right, right now we're going to talk about member functions and program organization. Member functions must be attached or bound to an object when called. Notice we have a member function called print here, defined in our little UML class. It has no arguments appearing inside of the parentheses, so it is just a print member function with nothing returned. Looking over here, we have 3 instances of the person class. One with the name Dilbert, one with the name Alice, and one with the name Wally. That's what this is over here. It is an error to call a function without it being attached to an object. How would this work? So if you tried to just call print, if you put this person class inside of a main and just tried to call print, without defining an object first, a person object, you would not have access to that print function first. Using that same cookie cutter analogy, cutting out many cookies using one cookie, it is possible to instantiate many objects from a single class. So PO, P1, and P2 are instances of a person, and all of the following function calls are valid. So this right here, print, is incorrect, while these are correct. And these would be more correct if they were numbered correctly. So this should be 0, 1, and 2 to match up with these. However, you get the point. You must bind your function call to an object. This is a class function, so that class binds it to that object, and then it will have access to that particular object's member variables. So taking a look right here, we are instantiating or creating a person object named P1. So it's a person, just like you would instantiate an integer. You're going to instantiate you would define an integer. You're going to instantiate this person, and then here we are using that P1 that's bound to that print function from that class, and it is now given access implicitly to P1's objects or P1's member variables. So the object becomes the default target of the function. Member functions and variable access. So first of all, let's talk about this. It is not common to put, it is more common, I should say, to put a function prototype into your class specification than it is to put a function definition. If the function definition is small, 3 to 4 lines, it is considered okay to do this. Kind of like what we see here. So we have about 3 lines here. So that's okay to have your function call within there. However, if it's getting past 3 or 4 lines, you're going to want to put that into a .cpp file similar to what we created with our struct time class. Notice here, though, then this is the second part I want to get into. The add function here has only one time parameter. How in the world is it supposed to add 2 times together to return 1 time if it only has 1 time parameter? Well, it goes back to what we said right here. So we have an object that's bound to the print function, giving this print function implicit access to the P1's variables. So here you can see we are only using the hours, minutes, and seconds variable names instead of tying them again to a T2 or T1 or something else that'd be passed in. So notice this is very different from how we specified it with our struct version. So we have integer I1 equals T1. So T1, that was passed in right here. So actually let's start over here. So we have the time return type. We have add name. We're passing in 1 time object and a 2nd time object right here. We are then giving these variables, we are tying them to those objects. And those variables are now copied over from that object into this in order to do operations on them. And that's then we add them all together and return using our old make time function. So in here, just say it one more time, the hours, the minutes, the variables are implicitly applied to whatever the object is bound to. So that is how it knows. So they are that object's hours, minutes, and seconds in this case. So here we have the struct version of calling those functions on the left. So we have z equals add. We're passing an x and a y, and it'll do that math and return that value to z. And in here, this is doing the exact same thing. It's just instead of passing that X in, we are implicitly saying that, hey, this add is now tied to this X. And so when it reaches in, it will automatically get this crowned version of being the main hours, minutes, and seconds, the ones that don't need to be tied to something. Implicit means implied or suggested, not visible, while explicit means fully revealed or exposed, visible. So you can see that these, whatever's being passed in as a parameter is the explicit argument, and whatever is being tied to that object is the implicit argument. So in summary, implicit arguments are on the left of the dot, and explicit arguments are inside the parentheses. So here we have object 1 and object 2. We're defining two objects. And then this left one we're making the implicit, and the right one we're making explicit. Let's talk about program organization. So the add function as it appears outside the class. So when we define our prototypes inside of a class, and we want to define our function from our prototype outside of the class, our function definition, we need to make sure that our program can connect the dots together. So the only thing different about this function is this little scope operator and then the name of the class that it's scoped to. So don't get all freaked out and see this extra bit of syntax and think that the whole program's changed, because it hasn't. You're still just defining the function here. You're just adding a slight little detail to let your compiler know that this function belongs to the time class. So you're giving the compiler, you're telling it what scope this function belongs to. So you're saying this add function belongs to the scope of my time class. All right, we'll come back to talk about these.